Hi, this is Mark Burrows from the Yorkshire branch of the Energy Institute, sat here with Kris to discuss metering developments for demand-side response and how perhaps technology is driving smarter and quicker demand-side response solutions. Hi, Kris.
Hi, Mark. I'm glad you didn't bother with your surname. Just call me Kris. It's a lot easier.
I'm happy with
And
that.
yes, yeah, yes. Well, we make meters, as you know, and so let's talk about metering and how you can use it.
Okay.
We're looking at technology and demand-side response and what you can do with it. Now, electricity is unusual in in the things you buy. You can't check the quality. Whatever they give you, you've got to put up with it. And then you can't store it, or you can't really store it. You used to have a big pump storage like the Norvik, and I can assure you, when it starts, it gives you a shock. I was standing on top of one of the turbines when it turned on. Oh, my heart just went so my stomach.
Okay.
Right, but you can store it, and with modern batteries and modern electronic systems, mechanical loads spinning, pressure vessels being pumped up, and all that can then be released when you need it.
Yeah, I think I'm aware of that.
Yeah.
There's a lot of talk and engagement in energy storage systems,
Yeah.
mechanical, electrical, thermal, and those sort of sorts. But what are National Grid doing about it? Well, how are they using that new technology?
Well, it's not just all new technology, it's a mixture. There's traditional technology, which is still being used, demand side management, where they try and manage the loads. They have arrangements with companies to shed loads at critical times, particularly, say, final half time, when the load can go up. The other side, and this is the newer technology, the demand side response. You can measure what's happening, and you can nowadays respond pretty quickly.
So National Grid have a series of products that they then activate in a response kind
Well,
of
they
basis.
don't activate, they do it themselves.
Okay.
The ideal thing, which National Grid would love, is a completely flat demand curve. No variations, no changes. In practice, it's very, very different. And what we've got here is a plot of frequency against time taken from a National Grid. 2 points to consider. First of all, the frequency is absolutely constant across the entire grid. It's got to be, otherwise the thing wouldn't work. The other way why frequency is a measure, if you think of it, a generator is something which is spinning. It's spinning, and the load being taken off is the electricity consumption. Now, if you try and put more load on, you're going to slow it down slightly.
Mm-hmm.
You know, if you're riding a bike and you put the brakes on,
it's going to slow it down.
Exactly. Yeah. It's as simple as that. So you've put a load on, the generator slows down slightly, and the frequency drops. And you can see that just after the beginning of the curve.
And am I right in thinking when the frequency drops too much, very crudely, the lights go out?
Ultimately, yes.
Ultimately, yes.
And it has happened. You had in the States and Canada about 7-8 years ago, the huge blackout.
Mm-hmm.
Now, the problem is, once you've got to that stage, it takes a long time to get it all running.
Yes.
Because you've got to synchronize everything.
Yes.
And that is a devil of a job.
And that's problematic. So obviously National Grid, in their wisdom, I defined a few products out there you may have heard of that are countering this problem to keep the lights switched on.
Correct. And there's the older ones you can see, which is the reserve on the slide. That's things like pump storage.
Short-term operating reserve one?
Yes.
Yeah, okay.
Yeah. But let's start at the fast end. On the left-hand side, you can see the frequency varying, and then suddenly a sudden big dip in frequency. Well, big, it's less than one cycle, but that is important because that is a problem. And here you've got the very, very fast response controlled by frequency directly. It detects the frequency has dropped, and within 1 second typically, it'll bring in additional capacity. It can be from batteries, or it can be by switching loads out.
Mm-hmm.
As you move in time and you're not really recovering, you've got the secondary loads coming in. Now, I'm sorry, Mark, but I don't understand these terms very
Yes.
well. I know how to measure it,
Yes.
but I don't
Oh,
understand.
I can help. Well, so
Yeah.
they bring in this primary switching, which is dynamic frequency response,
Yeah.
and then as you said, it moves in time.
Yeah.
It comes to these secondary options, which are more static frequency response,
Yeah.
and these are products and terms that National Grid are using just to react to frequency dip, trying to bring the frequency back up to 50 hertz, back to where the lights will retain and they're in a comfort zone. If they don't do that with these fast-moving products, they then can go to the older style, as I said, short-term operating reserve, balancing type services or reserve services.
Yes, and what they're trying to do, really, is to keep it as stable as possible. You want a very fast response, and it's got to be automatic because people can't react fast enough. Typically, as I said, it was within 1 second.
Mm-hmm.
That means they need to get readings within 100 milliseconds in order to achieve that. Just to sort of partially to make certain it actually is a problem. And secondly, it takes time for things to switch in and out.
And this is where the advance in metering technology is really coming in. So everything's, just for reference, is moving faster. They want a faster response. They need it to be totally automatic.
Correct.
For you out there, the user possibly, you'll get paid for that privilege.
Yeah.
But you will have to suffer some operational inconvenience. But yeah, so let's discuss more about that technology really, and in line with some of these terms and products from National Grid that are currently out there.
Well, for the fastest time, we have enhanced frequency response, which you've got to bring in on 1 second. And this is where we have the fast metering with a 100 millisecond measurement cycle, which can bring it in. But they seem to be pushing for faster and faster. Current developments at the moment are, in our labs, are to speed things up. Not just to reduce the measurement time from 100 milliseconds to 10 milliseconds, which is half a cycle, but also much higher, faster communication speeds. At one time, a standard Modbus running, 1 or 2 seconds for data was sufficient. We're now looking at gigabit connection to the meter.
I see. So that's very interesting for me because yes, it's a devil in the detail, but what that's showing, if National Grid and these large storage providers or developers are asking you for that technology, this is the way the market's going. So this speed of response from not just metering, but SCADA platforms, automation platforms, building management systems should hopefully follow suit as well.
Oh yes, because if you look at Germany during the recent solar eclipse, a lot of German generating is solar, solar panels. And suddenly, all that was being brought down to virtually nil. And the German grid controllers were basically chewing away at their nails. It worked. There was no problem. But this is the sort of thing that happens. You get an estate of houses, all with solar power. You get a small cloud that goes shadow, and suddenly, instead of generating, they're sucking.
Correct. So this is obviously a growth area, and I can see that ND Metering are embracing that area, which it is good, and it's good that a UK firm are doing that, and hopefully being at the forefront of the market. But it does speak volumes, I think, that the National Grid and developers are asking for this technology, and it's only going one way. So hopefully the listeners to this webinar could take that message going forward, and maybe inquire a bit more with their technology providers, with their metering providers, and with National Grid in terms of their aggregation partners.
Well, we hope so. We follow the market or try and lead it, but in essence, there's no point developing 10 millisecond if no one will buy it.
No. Just for reference, there is also a call or discussion about future frequency products out there at the moment. So feel free to go to the web address on the slide there. Lots of information around this subject area. But I think it's been invaluable to connect with someone like Kris, who is at the forefront of the R&D in the metering side of things. And that gives you that heads up. So I'd personally like to say thank you to Kris. And
thank you very much.
And thank you for listening as well.